Hey there, it's Mrs. Lake, and I am going to go through the elements and compounds of Earth, digital INB with you. First of all, the first slide, they basically just want you to reflect on the essential question before you dive in. The essential questions are: what elements mostly make up Earth, living matter, oceans, and atmosphere? And what is the difference between an element and a compound? We've talked about both of these things yesterday in class. So, what elements mostly make up everything? And what is the difference between an element and a compound? They also want to know, if you were quizzed today, which questions would you know the answers to already, and which questions would you need to learn more about to answer confidently. So just go ahead and hit pause and answer those two questions for me. Okay, now that you're back, let's go to the third slide. We're talking about matter. Matter is everything around you. Anything that takes up space is matter, and matter is made of atoms. But what we have to remember is that matter can be in three different states. It can be a solid, it can be a liquid, or it can be a gas. So over here, it says, what is another way to say takes up space? So what could we say something is if it takes up space? It's almost like it was over here in white. So go ahead and jot that down. And then let's go to slide 4. Slide 4 talks about the solid phase of matter. Solid means it has a definite volume and definite shape. As you can tell here, with the ice cube, there is definitely a certain amount of water or ice, and it has a definite shape to it. That is a solid. In a solid, the particles are tightly packed. If you'll notice here, they're perfectly put together. They do not flow easily. They cannot move or slide past one another. So they want you to come over here in the box and describe what is the volume and shape of solids. I'm even going to help you out on this one. We could say that, first of all, there we go. Solids have both a definite shape and a definite volume. We just described the volume and the shape of solids. We know they have a definite shape and a definite volume. Going on to slide 5, we talk about liquid. Now, liquid is a little different. It has a definite volume, because as you can see in the glass here, there is a definite amount of water. But liquids have no definite shape. Liquids can float easily. They move past each other. They're fluid. There's lots of free space between the particles. And basically, a liquid will take whatever shape of the container it's put in. So if it's put in a tall, skinny glass, it's going to become tall and skinny. If it's put in a coffee cup, it's going to take the shape of a coffee cup. Liquid just takes the shape of whatever it's in. So then when you come over here, you can pause this and go up here to the top and describe the volume and shape of liquids. Yet again, in a complete sentence, what do we know about liquids? If you can't remember, you can go back to over here where we put the solids have a definite shape and a definite volume. Well, what do we know? What do we know about liquids? Next, we're going to talk about gas. Gas is completely opposite of both a liquid and a solid, because gas has no definite shape and it has no definite volume. Gas is just there. There's lots of free space for the particles to move. It moves really easily. It flows easily. And gas is going to take both the shape and the volume of its container. So that's why we can have canisters of oxygen. Gas just takes whatever shape and takes the volume of whatever it's put inside. So then you're going to come over here to the right. You can pause it for a second and answer if you want to. Describe the volume and shape of gases. So then they want you to think about it. They want you to use your knowledge of matter to figure out the mystery substance. So this substance has no definite shape. It's often used at birthday parties. It has no definite volume. It is an element on the periodic table. It is less dense than the atmospheric oxygen, which means it's not as heavy, and the substance flows. So what do you think that we're talking about? You can come over here and put your answer for us and tell us what you think it is. So when we talk about elements and compounds and mixtures, there are lots of words that you're going to hear us use. These are all things we're going to talk about when we talk about matter. You're going to hear elements, compounds, molecules, and mixtures. We talked about elements, compounds, and mixtures in class, but we did not talk about molecules. But we'll talk about that here in just a minute. First of all, we can't forget Dmitri Mendeleev. He's the Russian chemist and inventor who formulated the periodic table. He is the one who arranged the elements into the periodic table by atomic weight and similar properties. He's also the one that predicted the properties of 8 elements that were yet to be discovered. So when Mendeleev did the periodic table, he didn't even have everything that he knew was going to go on there. We have to remember that atoms are the smallest units of an element. We then know that atoms make up matter that can be elements. An element cannot be broken down into any other substance. It is represented on the periodic table by a symbol. For example, Au is gold. So our question now here is, what is the smallest unit of an element? If only we had seen the answer to that question somewhere. But I'll let you go ahead and pause it and put your answer here. What is the smallest unit of an element? Okay, going on, matter can also be made of compounds. Compounds are when 2 or more elements have chemically combined through a chemical reaction to form a new substance. What we didn't talk about today is that compounds will be represented by a formula. For example, like we talked about in class, NaCl is sodium chloride, which is salt. So the question they ask is at least how many elements are needed to create a compound? How many elements are the fewest amount of elements we can have to create a compound? Another word that we can use for a compound is a molecule. A molecule is any 2 or more atoms that have been bonded together. So elements can naturally occur as molecules. They have 2 or more of the same atom bonded together, like O2. So a molecule is any 2 or more atoms bonded together. Molecules that are compounds have 2 or more atoms of different elements. So you can have molecules that are the same atom bonded together, or you can have molecules that are compounds that have 2 or more atoms of different elements bonded together. For example, H2O, you have 2 hydrogen and 1 of oxygen. That makes a compound, but it is also a molecule. So over here on the left, guys, you'll see that molecules are the smallest unit that keeps the chemical properties of a compound. For example, a water molecule is a compound that's normally liquid. Dividing water anymore would create atoms of hydrogen and oxygen, elements which are gases. So over here on the right, it says, what is the smallest unit of a compound that keeps the same chemical properties? Well, we know by reading the sentence here, molecules are the smallest unit that keeps the chemical properties of a compound. So the molecule is the smallest unit of a chemical property of a compound. So if we have 1 H2O, we have 1 molecule of water. And that's the smallest it can ever go. Now, we also can count the elements in a molecule. It says to count the number of element symbols, a compound will always have at least 2 elements. And how you can figure that out is by each element symbol has one capital letter. So if we have an NA, we have a capital and a little case, and then a large K, a low uppercase O, we have two elements because we have sodium and we have oxygen. So where it says how many elements are shown, you can put 2. Now what they want you to do here is they want you to explain the differences and relationship between a compound and a molecule. If you'll remember, we can go back up here to slide 12, and it talks about the fact that a molecule is any 2 or more atoms bonded together. So we can talk about the relationship between a compound and a molecule is that they are both 2 or more atoms bonded together. However, a compound is different because it has different elements bonded together. So a molecule can be 2 or more atoms bonded together, period. But a molecule that is a compound has different elements bonded together. So that's what you need to understand here, is what is the difference between O2 and H2O. So go ahead and pause, take a few minutes, and write the differences down there. You can write this in your own words. How do you see the differences? Then moving on, slide 15, we talk about elements and compounds again, but this time we're talking about a mixture. What is a mixture? A mixture is 2 or more atoms, elements or compounds, close to each other but not bonded together. Basically, a mixture, as they say here, is a physical combination of materials, which is a really good way to put it. The parts of the mixture aren't changed by being in the mixture, and there's no chemical bonding. It says typically mixtures are easily separated by physical means. Over on the left, it says mixtures are like a bag of frozen mixed vegetables. The carrots, the beans, and peas are not changed into carrot peas by being in the same package. They don't change from liquid to solid or change their chemical properties. You could easily go through and pick out the peas if you don't want to eat them. That's the difference in a mixture and a compound. A mixture can be taken apart physically. You can go in and pull off the parts you don't want. So here on slide 16, what they want you to do is they want you to find the formula. Then they want you to find the number of elements and the element names. So like for instance, we'll do NaCl together. So Na, we know is 2 elements. And those elements would be sodium and chlorine. And so what you're going to do is you're just going to go through here and find the rest of the formulas and then count how many chemicals they have and how many elements they have, and then what are the names of these elements. I'm going to go ahead and put this one back out here. So go ahead and pause and do this real quickly. Okay, there are many elements all around us. Some are solids, some are liquids, and some are gases. There are 90 elements that occur regularly in nature, but most of our world is made up of just a few elements. So they want to know here, how many elements occur naturally? If only we had that somewhere on our slide. Slide 19 talks about oxygen. Oxygen is found in the Earth's atmosphere, ozone layer, Earth's crust, water, and plastics. It's usually in the form of a gas. It's needed for survival, for us to breathe. It's in nature, water is a compound of oxygen. And an interesting fact is that oxygen is actually a very reactive element. You cannot have oxygen around an open flame. Silicon. Silicon is found in construction materials, ceramics, computer chips, rocks, glass. It is usually in the form of a solid. It's needed for added support in glass and as a semiconductor. Found as compounds in nature, but never by itself. And an interesting fact is that silicon is found in your skeletal system. Nitrogen is found in the Earth's atmosphere, in steel, coolants, and soil. It's usually in the form of a gas. It is also needed for breathing and for plant growth. It exists in nature as a compound important for life. And an interesting fact is that it makes up over 80% of the Earth's atmosphere. And if you'll actually even look over here, it shows where 21% is oxygen, 1% is inactive gases, and 78% is nitrogen. 22, we talk about carbon. We talk about carbon in class. It's found in plants, charcoal, plastic, graphite, petroleum. Carbon is normally in the form of a solid. It's needed for survival of all life on Earth. It also exists in compounds in nature. And an interesting fact is that diamonds are large pieces of carbon that were under high pressure until it crystallized. Then I just want you to look here at the pie charts, and it says that it represents the most abundant elements in the different parts of Earth. Use the legend to drag the correct list to the matching chart. So basically, you need to pick which list goes with each chart. Right here, you see, first of all, we saw some of these charts on the other slides, but also this right here only has 3 parts to it. So it makes sense that this would go here. Also, if you look, you have it color coded. You have nitrogen, other, and oxygen. Nitrogen, oxygen, other. So that's how you're going to do this. So go ahead and pause and see if you can put these with the correct pie chart. Next, it says, think about it. After spending a day at the beach, you leave a bucket of shells, sand, and salt water outside on the patio. When you go to gather your shells from the bucket a few days later, you notice all the water is gone and there are white crystals on the bucket. What happened? Was the salt water a compound or a mixture? What about the sand, the shells, and the water? And how do you know? Finally, they just want you to go through here and read the descriptions below. There are bold words, and each cover up the incorrect words with the blocks. So, for instance, was it Dmitry Mendeleev or Gregor Mendel that was a Russian scientist who created a periodic table which organized either elements or molecules by atomic mass and similar properties? Well, first of all, we know that it was Dmitry Mendeleev who organized elements by atomic mass and similar properties. So you see there's a number with each of these. You just need to go through and cover up which one is the incorrect answer. And I just gave you 1 and 2. Then finally, you need to answer what element makes up Earth, living matter, oceans, and atmosphere? What is the difference between an element and a compound? And what do you still